Okay, so on the worksheet, and this reviews what we were doing last week. So make sure you have this down. It will be on this week's quiz again. Every single one of you should be following along either with your notes or on your worksheet. So as we go over this, this is the worksheet you're looking at, but I have another picture from the book that's the same one we used in the other notes. So let's take a look at these and match them up with this. So this picture is straight from the textbook, but with this picture we can answer all of the questions that were on that front page. So the first one, name and describe the feature shown at A. So again, what do we have here in your picture? This is what it's showing. So what is this feature here? Who can tell me? So number one, name and describe the feature of the ocean floor shown at A. And again, you guys have this picture, but it's the same thing. So it's the mid-ocean ridge. Describe it. It is a volcanic mountain range in the center of the ocean. So volcanic mountain range, very long mountain range. We looked at it on Google Earth the other day. You've got volcanoes here, new crust forming. And again, this picture from the book shows the same thing, just slightly differently. Describe the process shown occurring at B. And so B in your picture is just a bracket over this area. So in the area around the mid-ocean ridge, what is happening? What's happening in that area around the mid-ocean ridge? So if we look at this, what process is happening in B? Yeah, seafloor spreading, volcanic activity, new crust is forming, it's a divergent boundary. All of those things are correct. And all of those things we can see happening here. So the oceanic crust, and it's spreading apart this way, divergent boundary, new crust is forming, and this is called seafloor spreading. We talked about it last week. The next question follows right along. What happens to the old oceanic crust as the new material comes up? So as new material comes up here, what happens to the older crust? Before it gets destroyed, what happens to it first? So as the new material rises, the old oceanic crust is pushed to either side, and then the arrows on the ocean floor show the spreading of the ridge. What kinds of evidence? And again, we went over this last week. What are some of the different types of evidence that the crust is actually forming and that the plates are moving? Yes. Sonar gave us evidence that the ridge is actually there. What else? We can actually see that there's molten material. You can see that there's magma and lava, that it's cooling. What else? Yeah, we talked about that magnetic striping that it forms in the magnetic fields of the Earth, but the magnetic fields move. But we can see that they're symmetrical on both sides, confirming that they are moving apart. And what else? And this is drilling samples. So they're looking at the age of the rock. They can tell you that the rock over here is the same as the rock over here. Again, and that's mostly from last week. And then the final piece, what is happening here at C, at this part of the boundary, which this is a little bit more colorful view, but what process or what's happening here? What's happening here? So what's happening here is a subduction zone, and all those bits you were saying are true, right? So the oceanic crust, remember, is denser than the continental crust. So when they collide together, they get pushed together. And as we'll see with our kind of demonstration today, as the one runs into the other one, it makes this deep trench. The trench is formed as the more dense oceanic crust runs into the less dense continental crust and kind of drags it this way. But then what ultimately happens is it gets pushed all the way down into the mantle. As it melts, you get heat and pressure. And what's ultimately going to happen is you're going to get volcanoes here. So the new crust that was formed here, probably millions of years later, ends up being destroyed. So it is kind of a cycle, although a very, very slow one. But again, you see here, it says oceanic crust created along the mid-ocean ridge is destroyed at the deep ocean trench. In the process of subduction, the ocean crust sinks down into the mantle. Okay, so that's pretty straightforward. Any questions on that first part? Okay, then if we look right here, these ones I would say are less important, but I do think they're easier. So let's quickly look at these answers. Device that scientists use to map the ocean floor is sonar. I will not ask you that. The feature on the ocean floor at sea is called a trench. Yeah, trench, going back to that picture, C was right here, C's the trench, okay? The process that continually adds new material to the ocean floor is, that's convection down there, seafloor spreading, right? Oh yeah. The process by which the ocean floor sinks into the mantle is called subduction. And now, oh wait, the chain of underwater mountains along which the seafloor spreading occurs is? Yes. So again, just kind of a little more detail from last week, but that should make sense. Questions about any of this? Okay, and then moving on, finally, this was the last section of the chapter, and last week we just started into it but didn't get very far. So again, let's go back and compare my notes with these notes for what you need to know. These are, in fact, the pictures we put on the pictures I put on the quiz. But looking closely here, this very first picture, which type of boundary is this? So, okay. Right, no, because see, they're moving apart. They're diverging, moving apart. Yes, yes. This next boundary here, yes, is convergent. And as we'll talk about on this next question, there's actually different types of convergent boundaries. This convergent boundary is also a subduction zone, but we'll get there in a minute. And then this final boundary is transform. And really, when you think about it, divergent means to move apart. Convergent means to move together. So those two are easy. Transform is a little bit confusing, but we can manage that. So let's look at this, and I'm going to switch back to my other notes. What happens when the different types of plates collide? So we look at a little more detail for these three boundaries. And let's jump to this one. So question 4 asks, if you have two continental plates running into each other, what's going to happen? Mountains. Or if you have two oceanic plates running into each other, you're also going to get mountains because they're of the same density. And so what happens when they run into each other? They just push upwards. So these two different plates running into each other are just going to push into each other because they are the same density. And so they just push into each other and it kind of moves upwards as it pushes. So convergent boundaries, if they're both continental or if they're both oceanic, are going to make mountains or plateaus. This is the same force that's causing India to move into Asia and cause the Tibetan Plateau and the Himalayan mountains. Mount Everest is still growing taller. The Rocky Mountains, I believe, are also growing taller. It's a slightly different force. But then the other thing you can have, as we were talking about, is a subduction zone. And a subduction zone is happening when you have the continental crust crashing into the oceanic crust. And so then what happens here is the oceanic crust is less dense. So as they crash into each other, it's getting pushed underneath. As they crash into each other, it gets pushed downwards, and then this is where a trench forms. And as we will find out, this is going to create some of the most destructive earthquakes and the most violent volcanoes in this type of plate boundary. So that's subduction. And that, I believe, is all of question 4 there. And then number 5, what force of the movement of continents from one? Yeah, and so that's just convection currents in the mantle, right? Alfred Wegener did not have the evidence of the seafloor spreading the convection currents, and that's what actually is powering all of this. Okay, and then finally, last of all, let's look at the quick fill in the blanks here, which again should be really fairly simple, right? A scientific blank is a well-tested concept, a scientific theory, well-tested concept. Breaks in the Earth's crust where rocks have slipped past each other are called faults. A transform boundary will have a lot of faults too, but this is, and we're going to get into this more this week as we start talking about earthquakes. But when the crust moves enough that it's causing cracks or splits, that's what you're going to get. The lithosphere is broken into separate sections called plates or tectonic plates. A blank is a deep valley that forms along a divergent boundary on land. Okay, so this is important. We've talked a lot about the mid-ocean ridge. So a rift valley is a deep valley that forms along the divergent boundary. And yes, there is volcanic activity there. And there's one very famous one on the Earth. Anyone know where the Rift Valley is?
Grand Canyon. Grand Canyon.
No, everyone guesses the Grand Canyon. Grand Canyon is not volcanic. It's a river valley carved by the river, right? The Rift Valley is in Africa, the African Rift Valley.
No, it's not.
And this one is, of course, plate tectonics. I'll show you a picture of the African Rift Valley. We'll come back to that. There also, strangely enough, is a Rift Valley through New Mexico as well. Lesser known, but I will show you a picture of that. So with the last few minutes, you can start working on this. For the last few minutes, start working on this. We will pick